Hello everyone. Okay, we've already covered standard normal distribution. This is non-standard normal distribution or non-normal distribution. Really what this is like real world applications, because the majority of the time you're not going to get your mu and your sigma to be well to equal 0 and to equal 1. It's just not going to happen. So what you need to do is you need to be able to make it into normal distribution and use your z-scores, and this is a way to convert, which makes interpreting your data so much easier. But for right now, let's work some homework problems to be able to look at it. So you have a series of homework problems in there, and they're pretty much all based off of IQ scores, which is a very common uh, standard normal distribution, the way IQ scores work. That being said, we still don't end up with a mean of 0 and a standard deviation of 1. Our mean is 100 and our standard deviation is 15. So we're going to use this formula to be able to convert. All right. So what they want us to do, find the area. So find the area. So in order to find the area, I know I need a z-score, and this is all that they give me. Well, at least my standard or my density curve right here is reading from left to right. So what I look up, what I calculate, I can then look up on my table without having to do anything else. So I'm going to use my formula. But what I always like to do, because I do not like all the sentences and the words written in my problem, I just want my data. I memorize my formulas, and then I know what I need to have. And in math, and I hope that this has been a cognition for you, or if I say it, you're like, yes, I do realize that, is that you'll have some kind of formula, something set up. And more or less, we just plug in information in that formula, and there will always be one thing that's not there, and that's what we're trying to solve and find. Right now, what we're going to do is I'm just going to highlight all that area that they've given, all the information they've given me. They've given me mu, and it's 100. They've given me sigma, and it's 15, and they've given me x, which is 85. I'm going to take this information, plug it into my formula, and get a z-score. So I end up with z equals 85 minus 100 over 15. And I end up with a z-score that is a negative 1. Which makes sense. That's what it should be. It should be negative because it's to the left of center. Okay. I have a z-score of a negative 1, and I'm going to use my table and look that up. And for my z-score of a negative 1, 1587. So what this correlates to is a probability or area under the density curve, 1587. Or I could even say it like this. This IQ score of 85 or lower represents about 16% of the population. All right, another problem here. This is, they're looking for a range. They're looking at how many people, what percent of the population falls between an IQ of 75 and 120. So I'm going to have to use the formula twice. And again, I'm going to break this down. This is like a problem in 6-1. I'm going to draw two density curves here and do my math underneath them. What I'm going to have is I'm going to have this one here. That's the IQ of 120. And I'm finding the whole area all the way from the left to 120. But see, I found too much once I do that. So what I'm going to have to do is subtract something. And what I'm going to subtract is this area right here. Again, my table's giving me readings as though I read my density curve from left to right. So if I find this area and I do a little subtraction, then what I'll end up finding is just this. So I have a mu of 100 a sigma of 15, and my x for this one is 120. Mu of 100, sigma 15, x of 75, and my formula z equals x minus mu, and this what helps me memorize it, or it may grow a little dense in my mind, but as soon as I look at it, I remember it. That's my formula I'm going to use for both of them. So I have a z equals 120 minus 100. See, I can already tell I'm going to have a positive answer, and I should end up with a positive z-score. It's to the right of center. And here I should have a negative z-score because it's to the left of center, and I will. And a little calculation. That is going to be a z-score of 1.33. And this is a negative z-score of 1.67. So get my table out and I look them up. So I want to look up a z-score of 1.33. So positive 1, page 2, 1.3 and 3. So that gives me, let's see, 9082, 0.9082. Minus, and now I look up, so page 1 on U for negatives. And that gives me 0.0475. And all I do is subtract them. So 0.9082 minus 0.0475. All right, 0.9082 minus 0.0475. It gives me 0.8607. And what this tells me is that the area that is shaded in is 0.8607. To be able to talk it to you is that what I'm saying is that this shaded area right here represents 86% of the people. 86% of the people have IQs that range from 75 to 120. Okay. Let's do one more. All right. So I have defined the indicated z-score, and what they've done is they've given me a probability of 0.6. So with this, I know that z equals x minus mu sigma, and mu equals 100, sigma equals 15, and x is, I don't know x, but I can find x, right? Can I? Don't think so. So this one's going to be a little bit backwards. What I'm going to do is I know that I can take this right here, this area under the density curve, the probability, and I can find a z-score for it. What I'm trying to find is that x value. I'm trying to find that IQ, so I'm not going to be able to find that, but I can find a z-score, and then I can rearrange my formula and solve for x. With this problem here, I'm going to use my table A2 and I'm going to look up 0.6 in my probabilities. That's going to be a positive z-score. And I look through here and I go to find a 0.6, and they don't have it, but I have two values. So I have two values. I have 0.5987 and I have 0.626, and I want to find which is closer. So let's see, this has a difference of 13, and this one has a difference of 26. This is the one that I'm going to use. I'm going to use that value, or that probability area under the curve, to find the z-score. And the corresponding z-score for that one, what was that? 5986. So that is 0.25. Okay. So I have my z-score of a 0.25. But notice, I'm not going from left to right vertical boundary. My stuff says from the right to a left vertical boundary. Well, I'm not going to use the complement. I'm just going to use symmetry. So I'm going to look up this to find, or to do my calculations. So this is my value for z, 0.25. Now I rearrange my formula to solve for x. So let's see, that would be z sigma plus mu equals x. And now I just plug in my values, negative 0.25, 15 plus 100, and then I solve for x. And calculator, I end up with an IQ score of 96.25. That's that's the lowest IQ score that will encompass 60% of the population. So from this 96.25 up to the highest. And guys, that's some example problems from non-standard normal distribution or real-world applications. Please watch your publisher's videos, critically think and structure your homework, and good luck on your homework.